hear me?
Yes.
Okay, perfect. Okay. Hi, everyone. My name is Manasi. Very excited to be here speaking with you all about simplifying MLOps with model registry. So I'm going to say hi to folks and then turn off my video so we can focus on the slides and hopefully preserve bandwidth for a few people out there. So welcome. As mentioned before, I'm the founder and CEO of Verta Inc. We are a ML infrastructure company that builds machine learning operation software. So before we get into what is MLOps, all of that, I'll start off with a bit of background on myself. As a lot of people in the audience today, I have a technical background as well. I finished my PhD in computer science at MIT. I worked on model management and diagnosis. My PhD work was this open source project called ModelDB that you can download today and use. It's an experiment management system, and our work at MIT kind of started this whole area of experiment management. So it's been really exciting to see that flourish and thrive across the ecosystem. So that's a bit about me. I've also had the privilege of doing data science at some of the big tech companies that you'll see has informed some of the product decisions I'll talk about shortly. What's Verta? What do we do there? We are a end-to-end MLOps platform. And so I spend a lot of my time thinking and talking to people about machine learning operations. I gave a talk on ML operations 2 days ago, which at ODSC, so do check it out if that is of interest as well. And towards the end, I'll show some screens on Verta, which will help situate where we fit in the large ecosystem. All right, so let's get started. I'm speaking about simplifying MLOps. I will cover what is MLOps, what is a model registry, for those of you who haven't really heard about it before. Why do you need a model registry? Then I'll cover how do you get started with one. And then finally, we'll wrap up with a few pointers for things that you can do. Okay, so MLOps 101. Most folks here are probably from a data science background, and you would agree that data science models have become fairly easy to build if you are using a TensorFlow Hub model, a Hugging Face model, Fast AI, scikit-learn. If you have some data and you have an off-the-shelf model, you can get pretty damn far, and that's what a lot of the blogs on the internet will also tell you. And that's what we see across the sort of commercial ecosystem as well. What is still pretty challenging is building intelligent products. So the challenges here are there's a lot of teams that use different tools. So you might be in scikit-learn, as I mentioned before, PyTorch, you might be using TensorFlow, Spark, and ideally your product is compatible with all of these different types of models and the way that they are built and deployed. So as we see more libraries being used for data science, integrating these models and libraries into a full product is becoming a big challenge. Second, operating and running models is typically outside of the data science scope, and I'll talk more about this in a few slides. This quote is from a large company that we work with. Every time that they wanted to roll out a model, they had to build a brand new inference service and then support it 24/7. And this is a company whose models serve millions of requests per day globally. And so this quickly became a massive challenge for the machine learning team. And finally, if you're a manager or an executive, you probably have seen this issue before where because there is so much heterogeneity in how models are built and deployed, there's no control or visibility into where the models are running, how are they running, and so on. So these are all of the challenges that we've seen in machine learning, taking it to production, keeping it there. The funny thing is that we've actually solved these problems for software with a wonderful stack that is DevOps. This is just a sampling of the different tools that are used in DevOps. So as you'll notice, on the left-hand side, we have development. This is your writing code, versioning it to Git, using a CI system to do regular testing, then doing packaging, then doing releases, configuration, monitoring it with APM tools, and then going back to improving the software in some manner. As you might imagine, ML is no different. We're still building software solutions with ML. So MLOps, broadly defined, is a discipline that helps you deliver ML models faster and more reliably. So it helps you go through the same loop where your planning creation now involves training of your models. You might be doing hyperparameter optimization. You might be testing out models from different papers, so on and so forth. But that's the core of MLOps, and we're seeing that there are tool chains forming in order to deliver MLOps. If you're coming from the data science world, you're probably familiar with Jupyter Notebooks or Studio, the libraries that are used there. We're getting a bit better with testing our models, whether through cross-validation or by using debugging and explainability tools such as the popular open source libraries listed here. What we find, however, as we go to the operations side is that the tools of today are really the same that software engineers use, things like Docker, Kubernetes, Grafana, so on and so forth. However, there is a well-known gap between taking a model that has been developed on the ML side and then pulling it all the way to operations. And there are three things that actually cause this challenge. The first one is there's very different personas who are working, or different people with very different skill sets that are working on the ML side and the ops side. The tool stack that is used is different. So people on the ML side, which are data scientists, they're used to building a bunch of scripts, working with scikit in Python or R. On the operation side, the software engineers are used to Docker, to Java, Go, Scala, whatever it might be, the language of choice. And so there is a big communication as well as handoff gap that exists between the ML and operation side. The final challenge that we see in enabling ML ops is that the current tooling is ML unaware. Most people here are probably not even aware, and I wasn't before I started in this space, of what these tools are. This is Prometheus. It is a metric system that does monitoring for Kubernetes. But Prometheus has no idea that something that it's running is actually an ML model, and therefore it requires different kinds of monitoring than, say, a web server that might be running in the system. So that's a sampling of the challenges that exist today in enabling ML ops. The focus of my talk today is going to be this transition. We're going to focus on how do we make the handoff between ML and operations easy. And I'll talk about how model registry is a perfect way to enable this handoff and how you can get started with it. But that's a quick overview of what ML ops is. There's a lot of great literature out there, or check out my talk from 2 days ago for more details on ML ops. Okay. So let's move on to model registry at this point. What is a model registry? Now, as I mentioned before, in DevOps, we have this very robust tool chain that takes you from dev to ops. But you'll notice that there's still a handoff between dev and ops that software teams have built for. For instance, you're probably familiar with one of these three. There is Docker Hub, which is a way where you can share your Docker containers. There's Artifactory, which is a way to share your binary artifacts. That's used a lot with Java binaries, C binaries, things like that. And then you have PyPy. A lot of us go pip install, my favorite library. What is actually being used in the background is a registry for libraries in Python, which is PyPy. And to dive a bit deeper, what each one of these software solutions enables is a way on the left for the developers to build a bunch of their code, to package it, and then to publish usable versions of their code in a central repository so that others on the development and operations side can start consuming it. And we have seen this particular paradigm be extremely useful across the board. So how does this translate to ML? We should be learning from it. So a model registry, similar to, say, an artifact registry, is a system that allows data scientists to publish their production-ready models and share them for collaboration with teams and stakeholders. So where it fits into your workflow is You're doing a bunch of experiments. You might be in your Jupyter notebook. You find some version of your model that works super well. You publish it to the staging area, which is the registry, and then consumers of your model can then pick it up from for deployment or for integrating it into their particular workflow. Where this sits in our view of MLOps is exactly at the center. Registry is what enables the transition of models from the left, which is very data science and research heavy, to operations, which is all about keeping the product running and operational. And as you might imagine, unless you have a model registry that is robust, high performance, you're not going to have this flywheel going between machine learning and operations. So we think of model registry as being the linchpin for MLOps and something that you want to invest in early on as you go about your ML journey. So next up, I'll talk about what are the benefits that you can expect to get out of a model registry. And then I'll also cover some ways in which you can either build your own model registry or use some off-the-shelf solutions. All right, first one, why model registry? I'm a data scientist myself. I know that data science is extremely messy. And the first goals of a model registry is to organize the exhaust from experimentation. I say organize because we don't quite want to hide it. We want to be able to go back to it when the time comes. So what do I mean? Data science ML research is ad hoc. I've been using these pictures for a long while, and yet every data scientist in the room can resonate with it. This is some of my screenshots when I was doing an Airflow sort of NLP project. Your scripts are typically a mess. There's the data sets, there's clean data sets, there's clean too. Your models might be living somewhere on S3. Quickly, all of this becomes unwieldy. And while experiment management systems like ModelDB can help, what model registry really helps you do is share only your best work with consumers. The thousands of models that you build during hyperparameter searching are not relevant to the software dev who's going to use your model to build the next Alexa or the next Siri. They only care about what is your best model and how can I use it. So that's where the mental model you should have for a model registry is data science does a bunch of experimentation. You pick the best models that you would like software to use, and then you publish them into the model registry for ease of consumption by other team members. So that's the first thing that a model registry is going to get you. The second one is related. Most ML models are rather finicky. Like if you wanted to retrain the model, then unless you had all of the following, which is what was the training data, what was the configuration, what was the set of libraries, and what was the code, it's going to be impossible for a software engineer to accurately reproduce your work. In addition, when you want to use a model, you need to have documentation. Like here is the input that the model expects, here's the output, here are the regimes on which this model can be used. And so a primary purpose that a model registry serves is it provides documentation and reproducibility for the models that are stored in the registry. So that's our first benefit of a model registry. The next one has to do with an area that's becoming extremely crucial as AI and ML is being more widely used. That is to bring governance and controls to one central place. These headlines are not new. All of us have seen them before. The lack of governance has serious issues for models, whether it's biased models, whether it's your biased data sets or data sets that have been trained with a certain section of the population not even included. It leads to both reputational damage, sort of personal damage for users of your system, and of course, revenue. As governance is becoming more and more crucial, we find that current practices are non-existent or ad hoc. And a model registry, which is the handoff between I have this great model, I'm going to write in Europe's paper about it, to that model is going to power my production, my products. Model registry ends up being an excellent place for you to start imposing the restrictions and controls you want on your model itself. For instance, here are two kinds of workflows we see a lot in model registries that we support. The first one is more an operational workflow where the approvals come in terms of when should a model make its way to staging? When should it make its way to production? When should it be retired and archived? And having ways to instrument these workflows is what a model registry enables you. The second one has to do more with model risks, with model bias, explainability. Once you have a registry, that becomes the point where you can certify, in some sense, that a model has passed the checks that your organization requires before anyone can even use them in a product. And so more and more, we're finding that the registry is a crucial piece to use models in real life products. All right, the third one, which is what does model registry get you at a basic level? It enables rapid model rollouts. That is the whole point of DevOps and also MLOps. We want to make it super easy for the best model that the data science team has built to be integrated into products. What it looks like today is data science is running a bunch of experiments. Those models have to make their way to software. A lot of times, and I've been in this situation, this is enabled by sending a lot of panicked messages on Slack saying, no, the thing you're deploying is actually the wrong one. I sent you the wrong file, or I didn't send you the right API. We actually need this new feature that we enabled 2 weeks ago. The software engineer sitting out there is just like, okay, this is crazy. I need to have one configuration for running the model, and I can't keep going back and forth with the data science team to actually use the thing that they built. So what we want to do is to go from this very slow, frustrating, and often error-prone process to something that's enabled by the model registry. Data science does their thing. Once they have a model that's ready to go, they put it into the registry. They include documentation on how to use the model. And then the software engineers are self-serve. You have already provided them the information they need. They can just look at the documentation. They can maybe test out the model and then deploy it. Everyone is super happy. And we've seen this work over and over again. And it has, in our experience, given a 5 to 10x speed up in how fast models can be deployed to production. So to summarize, what a model registry gets you is it lets you organize the exhaust from experimentation. And experimentation is super crucial. You don't want to skimp on that because you want to get models to prod. It allows you to bring governance, and it enables rapid rollout of models. So that's why you need model registry. Let's look at what this entails for a model registry system and the things that you should be looking for when you're choosing a model registry. All right, so here I have the stages that are typically involved in rolling out a model. As you'll see on the left, we start with experimentation. Since the model registry needs to integrate with data science, it needs to integrate with experiment management systems. In our case, it's ModelDB. In your case, it might be homegrown or something else. Once a model is in the staging area, you want to enable sharing. You want to enable collaboration. If you are dealing with PII data, you want to be able to say which people on your team actually have access to the model, because there might be sensitive information in there. Here, we also want the ability to configure the governance and approval workflows that I talked about earlier, and having a very flexible way to specify who are the people who can actually promote models or approve models becomes crucial. Automation, I'm a big fan of automation. If you do something more than 3 times, you should probably automate it. So having some ways to trigger downstream actions, to trigger promotions of models through different stages like dev, UAT, prod is crucial. And this is also where high performance becomes very, very important. So suppose you are you're a large content provider and you build a bunch of models that understand what documents are about. In that case, you're going to be updating your models daily, if not weekly. And you don't want to be waiting, minutes in order for your new deep learning model to actually be downloaded from the internet and use it. So as you start building scalable systems, performance becomes a pretty crucial requirement from the model registry. And then finally, we have deployment. Model registry is a crucial step to enable deployment. And so a model registry should have good hooks into deployment systems, whether you want to deploy it to SageMaker, you want to Dockerize it, run it on your own system, whatever it might be. So those are just a few things that you probably want to be thinking about when you are either building a model registry or you are looking at off-the-shelf registries that you can use. Okay, so hopefully I've given you a bit of context on why model registries are important for you to put into your MLOps workflow. A reasonable question is, where do you get started? So learn more. Model, as with everything in machine learning, this is a new field, so you want to get educated on what are the best practices, what's out there. I wrote a post to go with this particular talk on ODSC that you can check out later. There's also good content from Docker and from Artifactory who have solved these problems on the software area. The second thing to do is to try to build a simple model registry. If you are a N of 1 or a small shop, you probably don't need something super fancy. And so you can get away with building a model registry that's just using S3, and you're using key value tags to keep track of your model, published model versions. You give up a few things like governance and controls, but you'll at least get started. And we got a lot of good feedback on this particular area based on the blog that is linked above. And so I'll be running a hands-on workshop at the end of April that talks about how to use S3 for building a simple model registry. So feel free to sign up there, and I'd be happy to put this link in the Q&A later as well. So if you're a small shop, explore that. You don't need a very heavyweight solution. Now, if you are a machine learning team that has a lot of models that need to make their way to production, there's a lot of governance you need to take care of, you should look at hosted model registry solutions. The big cloud providers provide ways for you to use registries. So if you're on Google, if you're on SageMaker ecosystem, you'll be able to find something that can meet your constraints. At Verta, as I mentioned, we develop an MLOps platform. And so I'm a bit biased. I think that our model registry is great. So what I'm going to do next is just walk you through what a model registry typically looks like and what it affords. And I'll just show the screens for the Verta system as an example of what a model registry should look like so that you can evaluate other ones that you might be interested in. Okay. So this is the Verta web app. If you want to get a experiment management system that's very similar, check out ModelDB. I'll throw up a link later. But I'm going to demonstrate the workflow that I just talked about. We're going to go from developing a model, experimenting it with it, registering it into the model registry, and then deploying it as an endpoint. And I'll highlight why model registry matters so much. So here we have all of the projects that you're working on. This should look fairly typical. I have some fraud, text search, census income, all of that. Within a particular project, you have experiments, experiment runs, an experiment run, the vocabulary that we came up with at Verta, rather at MIT, my apologies, is a execution of your script. And so that's where you're going to be tracking things like your hyperparameters, your metrics. You're going to want to maybe build charts based on your experiments that you have run so that you have a Tableau-like view of all the data so far. You want to be able to compare your models that you have built and see why you're getting certain changes or errors in your model. But at the end of the day, all of this data is only at the experimentation stage. So we call it development. You're still developing a model. It hasn't made its way to production. As you'll see here, our firm belief is once you have a developed model, you want to register it if you think that that is the best model. And typically registration looks like you are defining a registered model, and perhaps that's the census model here. I'm going to add a version name, maybe that's a 4. There can be approval and security restrictions that you want to apply here. And I'm going to go ahead and create that. And I'll show you what it looks like once you have things registered. So during development, as you probably saw, and let me just go back here. When I build a model, I actually have hundreds of these experiment runs. You don't want your software engineering team to deal with all of them. Instead, you want them to deal with a very small subset, which has only your best work. So in this case, for the census model, instead of the hundreds that I have going on, I have only 4 of these models that I want the software engineering team to use. So I've published them to the model registry. And in turn, what a registered model has with it is the experiment run. So you can always go back to where did a particular published model come from. It also tells you things like, when was it created? What were the artifacts associated with it? What was the environment, and so on. The crucial thing that I mentioned about approvals is you want to give the data science team and whoever is managing the release process the ability to promote different models to different stages. So maybe you start out in development, then you promote it to production, you say my best model, and then you actually ask for someone to approve it. This lets you layer in the governance that we were talking about and make sure that someone who's using the model is only using the best one and there is no miscommunication going on with the team. So this is at the registry stage, and we have layered in a lot of approvals here. What you will typically do next is deploy the model into production. And in an ideal case, a registry enables you to take the model directly into prod. In the way that I set up the demo, that takes the form of endpoints, which are just APIs. And here's one API that I have running already. But to give you a sense of what can be enabled once you have a registered model, you go ahead and you deploy it. And that's it. That's going to go off and it's going to create a Docker container so that you can go and start using the API here. So here's a curl command. You can go off and start integrating it into your system. So here's the API endpoint that I just provisioned. It's telling me it came from model version 5. I can go back and look at the model version. I can go all the way back and I can look at the specific experiment run that created it. So at this point, you've built a lineage that goes from this is my endpoint to this is my registered model, all the way to the experiment that the data scientist ran. So that's a very quick view of where a model registry fits in. I like to think about it as you start off with development, you're doing a lot of experimentation, then you move off to the model registry where you have only your best work. And once you have a model that is ready to be used more broadly, you move on to the actual deployments in your system, and I have a lot of them. That's where you can use these models and integrate them into a product that you might be building. Okay, so that's a very quick overview of what a system for model registry may look like. You might end up finding that this is a lot of features and functionality for you, and a simple S3 based solution might work. In that case, check out that one and see if that's a good fit. Okay, so we're done with that. I'm now going to wrap up so that we have a lot of time for questions. The key point that I would like you to take away from this session is as follows. MLOps is all about shipping ML products faster and more reliably. We want to make this infinite loop go as fast as possible. The handoff between machine learning and operations is currently very slow, frustrating, and error prone. The way to fix it is registry. Registry lets you collaborate and hand off work more easily. It allows you to layer in governance and controls at the step before you put a model into production. And it also speeds up your general pace of deploying ML models. And as I mentioned, you can start off small, simple, and then move to a vendor platform. I'll leave that here for if you want to try out the thing that I mentioned, check out the top link, and you'll be able to go through experiment management to registry to deployment. If you're into open source, that is the model DB system that is going to get you fairly far as well. So that's it in terms of the slides that I have. I would be more than happy to take questions in the Q&A panel, and also on the chat system for ODSC. So thank you. Okay, I'm going to switch to looking at the Q&A, and then we can see if there are questions that folks would like answered. All right, I see someone is throwing in a question, so I'm gonna pause until they write their question. Okay, so Eric says, thanks for the talk. I was wondering your views on using a model registry for transparency into performance, limitations, etc. of various models and the training data. Absolutely. I am a big fan of this idea, because model registry is the point at which you are sort of exposing to the world what your model is and how it should be used. So in our view, that is the place where you want to lay out in what way should a model be used, what are the limitations in terms of what data it's going to work on, what data has it been trained on, and what kind of accuracy do you expect to get. There's a really great paper from Google called Model Cards, that tries to address some of these questions that I'm a fan of, and I'll put a link to it. But absolutely, this is the place to be doing that. All right, I see a few more questions coming in, so please do keep them coming in. Let me throw in the model cards link. All right. So Hamid asked, feature stores as well as associated with that model. How do you handle that? It may have sensitive data in it, so it must be secured. Okay, so I'll give you our view of how we separate out models and data, and happy to talk more for your particular case. So the way that we have constructed our system in particular is that data sets are different from models, and you can have different levels of access control on all of them. So you might have a data set that has a lot of PII, and you want to only expose that to a very small subset of your team. The model, in contrast, might not have the PII, and so it can be exposed to a broader set. So in our view, by setting the controls on data separately from models, you can get pretty far. If someone is going to be using a model, though, they need to be aware, at least at an aggregate level, what kind of data the model has been trained on. Otherwise, they're going to end up using it in a setting where it should not be used, and it could either have poor performance or have reputational damages if used incorrectly. Okay. All right, Lucian asks, what are your interactions with model governance in practice? Yeah, so we find a few different asks for model governance always. One is more from the operations team, which is we want automation as a model goes from development to production, and someone, maybe it's a manager or a senior architect on the team, who should be approving these models before you actually use them in products. So that's the first one, very operations focused. The second one is around in what way should this model be used? In the sense, is it a high risk model? Is it a low risk model? What kind of data can you be using it on? For instance, maybe you have a content recommendation model. It can be used for, say, content that's in English, but you cannot use it for content that is in Arabic or Russian or whatever might be relevant there. We increasingly find the need to attach supporting documentation to these models. That might be a paper, that might be just a PDF that someone created that they want to preserve for posterity. And then finally, for organizations that have large regulatory restrictions, we also find the need for, has this model passed the bias checks, and has this model passed explainability checks? And so depending on the particular risk level of the model and use case, governance can turn out to be super, super rich. All right, I am gonna keep going. Is there a way to monitor drift? Yeah, absolutely. This is like a key part of it. We ran a machine learning operations sort of model monitoring salon at Verta yesterday. I will look up the link and put it in the chat. Absolutely, we think that that is crucial, and I didn't really go through it in the presentation, but it's an area that we do a lot of work on. So model monitoring. Okay. Okay, are the slides for the presentation? I know the recording will be available somewhere, and I'm sure I can share the slides as well. Okay, next one. So many MLOps platforms now. Do you know if there's benchmarking? Yeah, that's a great question. As with any sort of early field, there's going to be a lot of tools out there, and it can be hard to figure out what these tools do or not do. And the best way as it stands right now is to actually try out these tools and see, as it's called, the proof is in the pudding. Like a particular MLOps platform or a vendor might say, yeah, we do all of these 10 things, but you need to actually test it out with one of your use cases to see if they actually do that. So besides actually giving it a shot, there isn't a good resource right now. And because the field moves so fast, even if someone built the resource today, it would be out of date tomorrow. So the best bet is try out what's there and see what's a good fit. And I would also say, like, as you are looking at these platforms and you envision that you're going to need a lot more capabilities than are currently offered, because the space moves fast, there's value in looking at whether the vendor is going to partner with you to develop some of these capabilities, and if you think they have the right skill set to do so. All right, next question. You talked about using S3 for small shops. How do you start with model registry on-prem? Any blob store will get you fairly far, whether it's, let's call it artifact store. You might have a HDFS type system, you might have Artifactory. And if that's of particular interest, I'm sure like when we do the workshop, we can also cover that off. Let me put the link to that workshop actually in here so people have it handy. 1 second. And thank you for all the questions. This is the most fun part of the session for me. Okay. All right, so Hamid has a follow-up. I need to have it during inferencing. I need to pass data. Okay. Okay. All right. So what is your question on that? I understand you need to have a real-time data source and you need to have a training data source. And so if you could clarify that question, that'd be great. Okay. And then let me see. Okay, let me go back to this one. All right, I'm gonna give it just gonna give it a minute. People seem to be typing. Scikit optimize and support for Scikit optimize. 1 second, I'm just gonna look at, is this auto sklearn or sequential model-based optimization in Python? I think that this, to me, at least taking a quick look at it, this is just a library for building specific kinds of models. And I haven't looked very deeply into it, so feel free to add more details there. So I don't think this changes anything in terms of a model registry or experiment management. I feel fairly certain that even a system like ModelDB could integrate very easily into this. But if you have a more detailed follow-up on that, do let me know. It looks cool. I'm looking forward to checking it out some more after. Okay. So Hamid, I think to answer your question, depending on your requirements, feature store it's a fancy concept, but it's been around a while. If you think about feature stores have two flavors. One is the offline component, which is what the data warehouses used to support and still do support. In terms of the real time, that gets very close to online transaction processing systems, OLTP systems. You could also be using something like a key value store. Just use Cassandra for your for serving your real time features, and that's going to get you pretty far. There's also open source. There's also open source tools that are like Feast is one library that I'm aware of. That gives you a good experience for feature stores. Awesome. We're almost at time, but I'd be happy to continue the conversation on this channel, or as I had mentioned earlier, feel free to send a note, join on our Slack community, whatever is your preferred way to engage. I just put the link in there and happy to talk more there.
Thank you for speaking, Manasi. And thank you everyone for attending this session. Please stick around for a short survey to help the future conferences. Thank you again to Manasi and everyone.
Yeah, no problem. And Hamid, I will respond to you on the chat. I just got your question, but thank you all. This was very fun.